This conference will now be recorded.
Thanks very much, Ron. Welcome, everyone. We'd just like to kick off with introductions of the speakers. So I'll pass the microphone to Predrag to kick it off.
Good morning, and thank you very much for this opportunity. My name is Predrag Stojkovic. I'm Director for International Operation for RCMT. I have more than 30 years of project execution in high voltage substations and power plants all over the world, starting from Japan, Middle East, Dubai, Kuwait, Egypt, Europe, and obviously US and Canada. Working with different nationality, I realize how important it is to visualize and to present design intent to the construction crew and to your colleagues. And that's why I started using with my team 3D from 2008, and we are trying to implement all new tools and applications in our industry. Thank you.
Hello everyone, my name is Igor Geo and I'm a station design manager at RCMT, Mississauga, Ontario office. I've been in this industry for last 15 years this year, and I went through different phases of evolution of design, and that brought me in this position where I can actually, and I'm glad that I can actually speak about a new step in designing tools and as based on the BIM technologies, which will definitely improve safety, constructability, and reduce human errors. Thank you.
And my name is Ostap Zik, and I'm Manager of Business Development here at RCMT. Just a little background, I initially started as a protection and control engineer for substations and power plants, and slowly moved into incorporating intelligent PNC workflow solutions, and I work with Predrag's team and Igor's team on implementing intelligent design throughout the entire substation project lifecycle. So one question that a lot of people have, if they haven't really worked with intelligent design, is what is it? And just as a intro into it, it's basically using 3D models that have information baked in behind them. This is also sometimes referred to as BIM, Building Information Modeling. And it brings in an extra layer of intelligence into the regular engineering workflow. So we see on the right side here, there's just a short video playing with a fly through a 3D model, where information about the insulator is known, about the buses is known, about jumpers, and that's all stored automatically as engineers work on the system. And this isn't necessarily specific to a single set of software. There's a lot of different manufacturers out there that provide a PrintTech, Autodesk, Revit, it can all be used, but what we really try to push is it's not the software behind the this type of design. It's actually the people that implement it and use it on a daily basis. And what we're seeing here, some people might think is a scan of an existing substation, but on the right there, where it's shifting between the two images, that's actually the issued for construction model, and it's just syncing up with what we have on the actual as-built condition. So as we saw there, the changes are almost not even noticeable between the two shifts, and that's what we're trying to always get to: reducing costs, increasing constructability, and providing more value with this type of intelligent 3D solution. And why did we kind of get into this type of spaces? At the beginning of all of this, we were thinking, how can we better influence the project costs that our customers have? Because typically we'd issue a design, it would go to the construction contractor, and we kind of didn't have as much control at that point. If there's any changes that are required on site, they're going to be quite costly for the project. And that's what we could see here within this graph. As that project goes along, the cost of construction will increase with any change that you make, and any kind of ability to influence that cost really diminishes where you can make major changes at the beginning with relatively minor costs, and then at the end, even if you want to make some minor changes, it could end up being a large budget increase. And what kind of introduced us into this is Stanford University. They did a study years back, their Center of Integrated Facilities Engineering, on the impact of BIM and intelligent 3D design on major projects. And what they ended up doing is looking into 32 major industrial and commercial projects that were ongoing, and seeing what kind of difference they could see between them if the project was using BIM and if the project was using traditional 2D elements. And what they found is listed here on the screen: 7 to 10% better price estimating, and this is during bidding. So when their contractors could see all the elements of the design in 3D in these intelligent models, it gave a lot more understanding into the scope of work, into what has to be performed, what equipment would be needed, how much personnel, and just better accuracy into what's required of them. And that ultimately led to just during that time saving 7 to 10%, and in many cases that could cover the engineering portion of the job with those type of savings from the construction contractor. And so it's great to see that Stanford has that type of research done, but what we still get asked by a lot of our customers is, okay, but how have you impacted these projects in a positive way? So we had a project ongoing with a customer, and one of the things that occurred during it is that us, the construction contractor, and the customer, we put together a list of savings that could be attributed to using this 3D intelligent process and tool set. And here's just an example of one of them. On the right side, you can see that there's a structure. It's being placed directly onto a trench. And the reason this wasn't found is because the as-built documentation for the substation did not match the actual condition of the site. And one of the things that was done within this process is a 3D scan of the entire site. And that 3D scan alone was able to identify that this clash would occur, that there could potentially be schedule delays on site. Either the structure would have to be relocated, some design changes might have to be made. It would just go back and forth between maybe engineering and construction. And overall, the estimate here was $24,000 of savings just from this one finding. And just another example, a transformer was being moved through the station gate. We could see that right here on the right side. And what our team did is we modeled the equipment that our construction partner would be using. We followed the procedures that they wanted to use during that time, and we simulated what would occur with all the equipment there. And what we found immediately was if the high voltage, the primary bushing of this transformer was kept on, there'd be a huge clearance issue to an energized overhead line, and it would not be possible this way. So what this would cause, if it wasn't found so early within engineering, is that additional key personnel might have been needed, additional equipment, time. It would have some schedule delays, and overall a cost impact of around $50,000 onto the project, with again almost a no-brainer to find when you have these 3D intelligent tools available. And that kind of goes into how traditional engineering is done, and we still do some traditional engineering just because that's sometimes how it's has to be performed by, because of the requirements we have from our customer. But what we see here is that the different stages of the project are very walled off between each other. So conceptual design and planning, it'll begin with potentially unknown information about the site. Not a lot of history is known. You see what should be there based on the as-built drawings, and you kind of make a design that you think that'll work in that conceptual phase based on insufficient information. But then as that crosses over into engineering, that insufficient information could potentially cause issues because now drawings aren't as per the actual site. that could cause some material inconsistencies, so maybe not enough is ordered, and that could also build up into change orders by additional scopes of work for that engineering contractor when they might have a site visit and find that things aren't as expected. And if we go even further into the project from that engineering point of view, when that goes to construction, maybe the construction company is digging and they find some underground elements. It's unexpected for them, so maybe now they have to clear some rock, extend outages, maybe change the flow of work because of some unsafe work environment, and all that is kind of segregated again now just to the construction company, and it would go back and forth with engineering, but the chance to increase the amount of change orders for that project drastically goes up with those kind of clashes. And now what we try to perform when we're able to with our intelligent 3D lifecycle is to bring the intelligent 3D model throughout the project lifecycle. So it starts with planning, starts with the conceptual design, it goes into engineering, and it's also used within construction to improve the project. So basically what that means is gathering information earlier. So like we saw within one of those first examples, just having a scan of the substation allows project delays to kind of be ignored almost by finding these issues. It also allows for collaboration between the different groups. So that goes anywhere from the planning group, engineering, construction, and operations and maintenance teams. And what that allows is a much more robust design where different points of views can build up into the project and just make improvements that maybe the planning team wasn't looking at or the engineering team wasn't looking at, but from a construction or maintenance point of view is almost a no-brainer. And overall, this would increase transparency and minimize change orders and schedule delays for the project, overall leading to just value for the customer and everyone involved. And the first step of all of this is what we call reverse engineering. This is what's also known as laser scanning or LiDAR scanning of substations or power plants. And one thing our engineers always ask when we work on a brownfield project is, do we have a point cloud model? Just because the amount of time you need to kind of start up on the project and get an idea of what's going on with 2D documentation to compare it to a point cloud or a 3D model is just vastly less with that point cloud. You could immediately see what you're going to be designing in. And what we do with these point clouds is we develop models out of them. Again, intelligent models. So here you can see that we had some scans and we overlaid them with the photos that were made there. And we have the equipment in the background. All that equipment is tagged intelligently. A BOM is automatically generated. We're able to kind of improve on this design as needed without much changes to this kind of supporting documentation. Now, hopefully this video will play well, but we don't only just do substations and power plants. We also have done work in refineries. Here you can see a point cloud scan that was performed, and just some extra tray work was needed to be put in place within this refinery. And with that point cloud, it really allowed it to be much easier to design around the different piping that's there. And as you can see here, it's pretty congested. It's a pretty congested work space. So not only was this great for our engineers, but also with the construction partner working on this, they're now able to say, okay, I could or I can't get equipment into this area, or maybe we could move it to this different location based on some needs, and just overall provide that type of input that might not immediately be visible. Not only is it good for that, but if I just go a little bit further into this video, because of the accuracy of these LiDAR scans, you're able to even measure to millimeter accuracy of different points, either in the new model that you have or within the 3D scan or image that's being put together for this. And in addition to above ground, one of the big challenges with substations, at least, is below ground obstacles as well. So that could be anywhere from rock to existing utility equipment to maybe abandoned cables or trenches. What could happen is there's something that needs to be put into the site when construction gets there. They're digging and they find something that kind of is unforeseen and just adds to the cost of the project. So what we're also now actively doing is if there's below ground drawings, we can model those to have a better reference, but also perform GPR scans of the site and make sure that the elements that are on the drawing are actually what is on the site. And just even additional things, if there's some other utilities pipe that was abandoned 20 years ago and it's not on some drawings, we'd be able to find that and kind of negate the impact that it would have on the site work by informing everyone ahead of time. So after the reverse engineering portion, that could be done for both conceptual or mostly for brownfield work, but it's useful for both the conceptual and the engineering stage. But I'll start off with just some conceptual impacts of 3D intelligent design. So what we're able to do is quickly evaluate different designs. We're able to put this into a 3D model that's highly accurate. It'll comprise of equipment that's standard either to the customer, if we're working with just one with a customer that has a robust standard put in place, or we could use our own symbols that we have from our experience if there's nothing available. And what we can do with this is identify risks very early on into the project lifecycle. And like I mentioned before, from installation to engineering to construction to maintenance, all of that is just much more apparent when we're looking at 3D rather than 2D. And just an example, we had a project where we worked with our customer to do a feasibility study on a substation expansion. So what was done is we performed a 3D scan and modeled the site here. What we see on the right is just a regular AAS site. And what was required is that an additional ring bus was needed, and then that ring bus would have needs for future expansion for a transformer and a transmission line. So what was done is we took this existing model and we began to remove the equipment that would be removed with the project, and we implemented all the new changes into it. So here we saw that that there was definitely space within the site to include everything that was needed. We modeled the new structures, the new ring bus, the new circuit breakers, and this really allowed for a clear understanding of what the scope of work would be. But then when we started looking into the future requirements of the project, so adding that transformer and adding that that extra line, we saw that there could be minor improvements made throughout the design. And I'll just quickly go between the two images here. What we can see is that some of the structures in the existing design shift over to a new spot. And that's because when we were adding that extra line, that extra transformer, we had that insight. Okay, so maybe if we change this earlier on within this project, sure, the transformer can fit where it was and the new line could be fit, but maybe if we move this a couple of feet earlier on, we don't have to worry about the challenges later on when this future expansion would occur. And that just allowed now not only for the future design to be evaluated, but the base scope of the project to also be looked into and improved upon. And then furthermore, what we knew is that this site, it would be very close by to residential buildings. And at least a lot of people, and from a permitting point of view, wouldn't want to see very large structures in front of their house because of the substation expansion. So we also proposed the GIS option where that alternative, it would be better for a more permitting point of view, but maybe a slightly higher cost on the engineering, and that balance could be kind of reached between these different options. And just to go back onto that residential aspect, what a lot of the time we do is with our designs, with our conceptual designs, detailed designs, we put them over almost a Google Earth type of a street view. Here you can see just the existing substation. It's how it was, and when we overlay the new expansion design with the new ring bus, we see that the scale of this just becomes immediately apparent. So before, when we were looking at the engineering model for the planning stage, everything kind of just looks basically miniature, and you don't really get the scale there. But when you put this into the actual view that someone would be seeing, you just suddenly see, wow, so we'll really be impacting the site. And then similarly, we showed how that the GIS scope would also look like to minimize the visual impact from the site. And all of these documents and images, they really help with the permitting, with the planning for this, and the overall conceptual design for this. And now I'll kick it off to Igor to just follow up with some feasibility studies that we perform for indoor substations and greenfield projects.
Thank you, Ostap. So yeah, I'll take from here. Basically, Ostap done a great job presenting how our concept is done from beginning through the conceptual phase on the brownfield projects. And as you can see, the major idea is to collect correct informations and to have correct informations on a plate before you start making any decision. However, sometimes if we are lucky enough, we sometimes get a greenfield project, which by default is supposed to be something easier than brownfield, obviously. However, in certain cases, as the sample that I will use here, even though it's a green project, sometimes we have too many constraints. Like, for example, this substation particularly supposed to be in a downtown area, and obviously space was premium, and we should fight for every square inch of the space, basically. So from this, I will just switch to. I'll take a screen for a moment, and I'll just switch to interactive view to show you actually this building. So yeah, you should be able to see my screen now. So, okay, what you can see here is actually a model in front of me that has been developed during a feasibility, as a feasibility study, basically, together with one of our major clients, utility company, to work with for some time now already. And together with them, we developed this model. We had, as I said, really a lot of constraints here. As you can see, that's the reason why we have this odd-shaped building as a kind of L shape, where we actually had to fit 3 voltage levels, 345 kV SO6 GIS equipment, then 115 kV SO6 GIS equipment, and 14 kV, 14.4 kV medium voltage equipment as well. There are supposed to be a couple of high voltage transformers, even phase shifters, shunt reactors, and so on. So really, I mean, just by saying all of this, you can imagine how big substation is. And usually when planning take to do something about to define the requirements for the new projects. Usually, how it's done, it's on a high level, looking at the grid, looking at the overall studies on the area where improvement is needed, and then by having a one-line diagram, decisions start to becoming, on the table available, and some options what could be done to improve overall reliability of the grid, right? And at all of this, I mean, at that point, really people working on planning, they still looking at from really high perspective without thinking too much about physical space. Now, when need is defined and we end up having a one-line diagram and a list of equipment that would obviously follow up with the same, that at that moment, people start thinking, okay, where are we going to put this substation, right? We know what we need, so where we have a space to put that. And first of all, you try to put that to refurbish some existing substation, to expand, to add a bay or two, and to make changes and improvement on that level. However, in some cases, you need to get a step further and to build everything from, from bottom up, like in this case. So this is what we ended having here. It's a 3-story building, basically, with the basement for a cable entrance underneath. We had transmission cables 345, 115, as well as distribution cables here, as you can see in the red. So during the feasibility, we got some properties that we can use. So we should be clear, and if overall this can fit in that given space, right? So this actually, we started obviously from the largest equipment here. I'll just take some sections here of the building so we can focus on the overall work process that we got. Okay, so basically we started thinking about what is the largest piece of equipment, right? Obviously, in every substation, that is usually a transformer, or in this case also phase shifter, right? So first challenge was how to lay down all of this oil field equipment, that each of them requires oil containment underneath, and certain fireproofing, right? Walls, blast wall in between, and so on. How to fit them all in a space. Once when we've done that, when we fit them in, then we start thinking, okay, we have it here, but how are we going to install it, right? Do we have enough space in an aisle to move components? Actually, in this case, those components are only components on the screen and in our intelligent tool, but those components in real life are really huge transformers that need to be slid into the wall from the street, basically, and to get into the position where additional accessories need to be installed on them. So this was also part of we start thinking about immediately, because laying down layout without knowing how you're going to install that and checking if installation is possible or replacement later on really doesn't mean much, right? When you do feasibility study for any space, any given space. So once when we decided, okay, that this can work, we start going further and thinking about the switch gears. And this is what we got here. We basically jumped 2 floors up, right? And as you can see here, this is a 345 kV switch gear here, which is really big one, right? We have about 1, 2, 3, 4, 5 bays, which means of breaker and a half scheme. And on top of that, on a 115 kV, there supposed to be 8 bays breaker and a half scheme. Again, GIS switch gear. So somehow we managed to lay them in this arrangement here. Again, thinking about how we're going to bring GABs, in this case, to the switch gear, gas insulated bus, obviously, to the switch gear, how we're going to take cables out from here, where we're going to put distribution switch gear, which is at this room. Basically, it's end up here, right? And how to connect all of those. So, just laying a switch gear wasn't that hard, but how to connect everything to each other, it was really big step. And of course, again, just laying a switch gear doesn't mean much if you cannot connect it to the network, right? So that's why we start, even in this phase, thinking about all GAB routing here. Is it possible? Can we route them? Can we bring from the street all feeders inside? So we created hatches for a cables only, right? Going all the way to the basement, as you can see here. I'll jump into the basement, and this is how they are spread it through the basement. And then going all the way up into the switch gears on this level, ending up in this area where it's a medium switch gear located, and here high voltage switch gear, right? So all of that, once when we put all of that into the picture, into the same physical space, we could say that, okay, this is a feasible option. We can build this substation, right, from technical perspective. Oh yeah, I almost forgot, one of the major issues that we had was also ventilation, right? Because as you can see here, those huge transformers on this side are open to air, and we didn't have much problem with those, cooling them. But we had also transformers inside of building, right? We covered them here, as you can see. They're not open to space completely. So we created hatches for obviously for air circulation, and on other side of the building we create huge louvers to allow enough surface on the wall for air intake and air exhaust. So by having all of this, as I said, we conclude that this would be a feasible option to build, right? And you will now probably think, okay, this guy spent a year on this feasibility study, but no, really. I mean, complete this model, and with all back and forth, it was done in about a month and a half, no more than that. And I mean, we are a long time in this industry as well. We as Predrag mentioned in the beginning, we are in a 3D world. I mean, we trying using the 3D tools from 2008, and over the years we built our data sets for all different kind of equipment, right? So we have GIS equipment from major manufacturers because we've been working with many of them. We also have transformers, and you know, for pretty much every voltage level and pretty much every size that is around on the market. And you can see those models are not very detailed, right? But they are correct size-wise. And this is only what you need basically during a conceptual phase, because obviously you need to reserve the space. So once when we conclude that feasibility is right and we can go further, right? I'll just jump back into the my PowerPoint just to make sure we are on as per agenda. Yes. So once we step into the detailed design, so basically utility company get all approvals, and project is announced to go. Already on the kickoff meeting, we bring this conceptual model in picture for all stakeholders involved. And this is the first time when basically people from different groups, from different trades, all who are supposed to be involved in the project, in the designing of this substation, is involved and start thinking about overall space. This is great advantage because people just step into get up to speed really quickly, right? Because people are visual learners, right? And once when you have a picture is worth thousands of words, right? So once when you have a 3D model in front of you, you can really feel the space, and you can make you know, in your head what actually we are building here and what actually need to be done. So from that point on, obviously each group take responsibility of its own scope, right? We have a civil, we have a structural, building, electrical, we have building services. So basically there, let's say at least 3 to 5 or 6 group mechanical ventilation, right? So each group will take piece of this model and continue working on it and developing details and calculations, performing calculations, checking equipment, and so on. But everyone will still be connected to the major file. And that's the point of having intelligent tools to support this effort, because we need to have one source of truth in every design work. We want to avoid having multiple channels of information coming from all over the place. That's usually is not good for any design work, for any project, right? So everything what comes into the model, coming obviously from specialists in their own trades, but whatever they do, they add those items in one model that is given to everyone to see in real time. So basically, for us, electrical group, when we're pulling a high voltage or medium voltage cables through this building, we are aware of ventilation shafts or huge fans or area that need to be taken by elevator or stairs, so we can avoid them immediately, right? There is no need to lay everything down on a 2D drawing and then send back and then send to other people, and then who pulling design? Is it a civil? Is it a structural? Or is electrical maybe? No, in this case, everyone works its own part in real time in the same model within the same three-dimensional space. So that is all part of collaboration, right? But collaboration is not only sitting on a meeting and discuss a model. Yes, there is a big thing on that too, because of the brainstorming, because of the bringing a different problem, solving the problems. But in this case, also solving the clashes, because sometimes, let's say myself as an electrical designer, I know how I can route high voltage cable through some space. I know that I need to take care about bending radius, about pulling bending radius, final bending radius, about pulling forces through the conduits and so on. And at some point I hit the wall that somebody else placed somewhere else. And now that wall, it's something that looks to me important. I cannot just ignore it or avoid it within the 3D model space. At that time, I call for a meeting, right? And I need to discuss, obviously, with other group that put that wall in. So yes, we still have meetings, but meetings are always supported by having a 3D model in front of us and talking and pointing on the model itself. Ostap mentioned reverse engineering, which is again brownfield work. So now I will switch and talk a little bit about design, detailed design in a brownfield projects. Concept is the same, right? So you at the beginning, during a conceptual feasibility, you are taking your models, 3D models that you already have in your database, you're placing within the constraint that you got from the planning or conceptual phase, and you're checking the clearances and so on. We still have a civil. In some cases, civil need to do grading, right? To make, in certain cases, if our substation is on a slope, we would have more difficult situation where civil group need to create kind of cascades, right? Steps. And that all need to be coordinated with us, again, electrical designer, so we can make sure that our rigid bars following the same path and that top of concrete is always where it's supposed to be, you know, on a correct distance from the live parts and so on. So that's where intelligent 3D tools comes again in place. If civil group using let's say civil 3D, for example, and we are using again, let's say Inventor SDS, we can put together, right, those two and have really clear picture where the surface of the station is, where the top of the concrete is, and where live lines are. So in some cases,
Igor, we lost your screen. Igor, you lost your screen. Can you share screen again, please?
Okay, but okay. Let me see. Can you see it now?
Yep.
Yes.
I can see it.
Okay, so I don't know how much you've seen from this video. So I will just rewind a little bit. Okay. Okay, so I'm sorry. I didn't realize that you didn't see what I'm showing. It's good that you at least could hear me. So basically, yes, the point is that again, as having a greenfield, brownfield is the same story. You need to have a single source of truth, right? You need to have a single location where all informations are stored, not only stored, but also manipulated in real time between the different groups. So somebody has an echo in behind, so please, can you mute your microphone? Okay, and for brownfield, the difference, I mean, addition, we need more to think about, which is a 3D cloud, right? As you can see here, 3D cloud is just millions of points in a space that represent something taken from real world, and it's a great tool, really, but it's not always easy to work with. Whoever tried, maybe you need patience, you need to learn a little bit, you need to know how to optimize this point cloud so you can be able to work with. In many cases, we end up having a complete 3D cloud traced and modeled in a 3D by using a 3D solids and 3D tools. So on that way, we can actually regenerate as-built documentation, basically. And we like to call it as-is documentation because that's actually what it is, right? So it's taken from the site, it's taken by 3D scan, and it's converted to the 2D drawings at the end. So once when you have a 3D model, obviously, as it's shown here, you can do your design, you can manipulate really easy, right? With all components, add new equipment, check the clearances, and make sure that everything will work. But again, why we have 3D intelligent and why we call them intelligent tools? I mean, intelligence it's a human. Uh,
Igor, lost you.
Igor, we can't hear you if you can hear us.
Igor,
All right, let's give it a minute. Apologize
oh,
for
we
the
have some. Yeah, let's see if he will join up again.
yeah, let's have him reconnect.
Okay, he's coming back. Sorry, gentlemen, for this interruption, but that's happens sometimes.
No problem. Happens often.
We have backup host that can take over if Igor has a problem, but let's wait. Okay, looks like he's coming. He said he cannot unmute.
Let me see if I can find him and make him presenter again. Maybe that's part of the problem now. Let's see. Just muted him. Let's try to unmute him. Unfortunately, now I can't find him. All right, found him. Hang on.
He said the audio not connected. Good break, we can take a coffee.
Actually, that's not a bad idea. You know what? It's 9:53. Why don't we take a 5-minute break, everyone, if you don't mind? And sorry for the technical difficulties that happened. And we'll be back on in just a few minutes, I hope.
Yeah, thanks.
Hello, can you hear me now? It's Igor.
Yes, we
Yes,
can hear
Igor.
We can.
Okay, I joined through phone. I'm really sorry. Something happened with
Not a problem.
Can you share the screen, Igor?
A few minutes.
I'll try. I'm trying to join different way.
Igor, I do see you back. I just made you organizer again.
Thank you.
Okay. And I asked everyone to take a 5-minute break, so we've got like 2 minutes or so when we do get you up and running again. So we'll have to give it a few minutes.
That's great. Thanks.
So I also had a little worry this morning. I was up early today and had a pretty significant power dip 3 times in a row. And you know, I'm coming from a utility background. I was trying to figure out what it was and wasn't quite sure. And I said, "Oh boy, I hope the power doesn't go out today." These things happen.
Yeah, we're coming from the utility and engineering and the T&D. We understand what's behind if the power
Yeah.
goes on. So we really start worrying if anything start clicking.
In my case, the voltage dipped. It was strange. It dipped really low, and it stayed low for a second. So I figured, an adjacent feeder, but I figured something would have cleared. But the funny thing is, my printer decided to print an envelope. So I guess whatever the surge was, or I should say dip, I don't know, caused the computer to act up too. So happened 3 times in a row, and I'm a little bit nervous, but we made it. Do we have any utility people on the line today?
Whose territory are you in, Ron?
I'm in JCP&L territory.
Good. No.
Oh, that hurts.
I can't comment.
I used to work for them, so I'll take responsibility. I'll take blame.
We do not guarantee 24/7 service.
That's true.
Ron, do you have like a monitor on your house or something?
No. The only thing I have in my house is surge protection. Yeah, that one. I used to be a power quality engineer in a prior lifetime, so I used to be pretty in tune with that stuff. But this one this morning had me scratching my head a little bit. I figured, like I said, an adjacent circuit had some kind of a fault, but it didn't really clear. You figure it just clears and goes away. And it didn't have that 30-second cycle of a recloser, so I don't know what it was. Anyway.
In my neighborhood, we had 3 about 5-minute complete blackouts yesterday afternoon.
Really?
Maintenance they were doing, but it went down several times. That was within the course of about an hour and a half.
Yeah, you and I are not on the same distribution substation, but we're probably on the same transmission circuit.
Yeah. Did you have anything happen last night?
I wasn't home yesterday.
Ah, maybe you did then.
I think we are ready. Igor, can we start? Carry on. What's up?
Okay. Thanks, guys.
Yes, can you hear me?
Yes.
Yep.
Yes.
Okay. Okay, great. So I will try also to share the screen, and I'll continue talking. So
Igor, I'm not sure you're talking. If you are, we cannot hear you.
Igor, we cannot hear you. What's up? Maybe better you take over from here, and then if Igor join later on, he can.
Sure, no problem. So as Igor was discussing, we have these intelligent tools and models within the environment that we're designing in, where everyone can look into them. And what this means is anything that's changed within what you see here on the right, it's automatically propagated not only through reports for BOMs or anything like that, or quantities, but it's also being pushed through any type of drawings that we have set up based on these layouts. So what we see here is all these new structures, insulators, disconnect switches that we'll be putting in for this design change. And I'll just skip forward a little bit. When we go back out from this photorealistic view into the model, what that can also be used for is generating the 2D drawings. And now one thing that in the end is still required is that the PE stamp has to get put onto the documentation that we provide. And it would be quite difficult with a 3D model with just the amount of scale in there to just certify it all at once. So here you could see how that 3D model transforms into a 2D drawing. And then automatically we also have call outs that are placed onto the equipment, dimensions, sections, and all of that is in the background from the system. So what engineers can focus on is really working on the design and not really needing to focus, let's say, on the bolts and nuts or what's the span of a bus. That can all be in calculations. It's important to make sure that that's okay. But with the actual layout, that doesn't have to be really monitored in the back of your mind anymore. So when you shift a circuit breaker over a couple feet, if there's a jumper to it, that jumper will also be updated with its length, and you don't need to really worry about that entire process. And what that also means is, let's say you had a large design change that would overall impact the project very positively. Maybe the amount of effort that would have to go into redoing the design with all the drawings that could be impacted might just be too great, where you're going to have to maybe open hundreds of sheets of sections, of layouts, of bill of materials, and make major changes to them. And even though that design change is positive, it might be kind of put to the side just because what's there already is good enough, and the effort to update it is just too great. So moving on, this is something that Igor showed when he had his model up as well, and that's constructability. So that goes anywhere from installing equipment to maintenance to removal of equipment. So here from that same model that Igor was showing earlier, we have just a procedure animated how in that station the circuit breaker would be replaced and what kind of steps would have to be taken to get that out. And this is overall a very high detail model, or a low detail model that shows overall what needs to be done. But what we've done for other customers in the past is also provide procedures that are down to the bolts and nuts of what needs to be done in what order and how that procedure would come into place. And this isn't just useful for that kind of training procedure, but also just to understand how things are going to be done, where we're going to need free space if, let's say, this is coming in together with a electrical installation partner and the OEM, just to see what kind of planning needs to be done beforehand and evaluate both the construction and the maintenance and operations requirements for this equipment. So this could be anywhere from testing to construction. And just having all of this in a 3D space, here we just have the GIS crane, but if this was an AAS station, we'd be able to model in cranes or hydrovacs or any sort of vehicle or equipment that needs to be put into place to better visualize that space usage. So will we get too close to some equipment? If there's energized lines above, if the crane extends fully, is it within that approach distance? And just overall take it to the next level in collaborating the effort between engineering and construction. So another thing that what intelligent 3D design allows us to do is really design with safety in mind. So I think everyone on the call could agree that within our industry, safety is paramount in all the projects that we do, and making sure that everyone's coming home safe at the end of the day is very important. And we kind of like to take that onto our design, where when we're doing any kind of input into this, we're always thinking, how can we make this safer? One of the ways this could be done is either modeling in approach distances around equipment that would be energized, and making sure that as we plan these different elements of the project, we can see if things would get too close to it, or what kind of barricades would need to be put up prior to the work starting, just to make sure that everyone is safe. And this could go anywhere from in the site equipment, or let's say if a truck is coming near energized lines or going underneath energized lines, if there's some equipment on it, like we saw with the transformer at the beginning of the project, we could get that approach distance and clearance communicated to all the members of the team. So safety managers, construction managers, and also the safety teams. And what we really try to have done is when we're an EPC for a project is to use these safety deliverables, safety animations every day on the site. So when there's a toolbox talk, if we're discussing a certain task, we'd like the team to see that what work they're going to be performing during that time, what kind of hazards are there, and how that could be negated, and what we have set up to negate those, and to minimize that risk to safety. And what we've seen is that really increases the awareness of the team performing the work. And that also gives us a lot of feedback of how we can improve our designs also in the future. So we'll have safety managers coming back to us with safety forums, and oh, we have this noted. So we're always continuously improving what we can provide to the site teams based on their feedback to us and what we're showing them. And this is in a similar style to the safety video that we had and the slide. But what we have here is outage visualization. So some of the projects we've done before are extremely complex with how outage planning is done. We've had some projects of 12 to 15 outages occurring, and just because of how much work has to be performed with the site, it could almost you could almost get lost in what's supposed to be performed each time. So what we'd like to also highlight is during what outage, what lines will be energized, what work has to be performed. So if we have to remove some equipment, we'll outline that. If we need to install it, similarly, that would be included. And this could all be pulled within that 3D model. So everything is referenced to some tags. And if we have a construction schedule or an outage schedule available, we'd be able to also link that into these to provide a better understanding to not only the end customer and the stakeholders, but also our construction partners. So they can more effectively plan, okay, during this time, I'll need this equipment here, and I'll need this key personnel. And maybe I thought that I need more people based on what was in the drawings, but looking at this really gets idea across of what really needs to be taken into consideration. And by just highlighting what's needed, what's energized, what's not energized, that also puts an extra level of safety understanding with how we'd approach equipment. And with construction support, one of the final things that we have here is work procedures. So what we can do here is this works for both installation procedures, for maintenance procedures. We can highlight the procedure that would be required to install equipment or to remove equipment, to access equipment. So here, what we have in this video is transformer removal and installation for a project that we did. And from a very high level, we can quickly convey the information that we need to anyone that would be performing the work. So without as much time required for training, we'd be able to get people aware of the work being performed and how to perform it. And again, so this kind of ties back to what I was saying previously. This also can be as detailed or high level as needed based on what kind of work to be performed. So if we need some testing on, let's say, station service transformers, we can highlight where certain probes, where testing equipment could be attached to, where oil should be tested, and kind of minimize the need to almost imagine what you're seeing in written procedures, and that just greatly increases the understanding of the work that has to be performed. Now with 4D and 5D visual scheduling, it's something like the next step out of 3D intelligent design and how we support our customers. And I'd like to pass it on to Predrag Stojkovic to discuss about that.
Thank you, Ostap. I'll share my screen now. Just to confirm, do you see my screen?
Not right now, no.
Let me try again. Okay, do you see mine now?
No.
Not yet. Nope.
Strange, I can see it.
So what
Okay,
am I doing wrong here?
Yep, now I can see it.
You see now, Substation?
Yep, I see now.
Okay, so what you've been hearing so far is the implementation and using the 3D technology, wherever it is, during the conceptual design, detailed design engineering, coordination between all parties involved in the design engineering for the project. Now, once when you finish the engineering and you submit IFC, that's how, as per old standards, the engineering company will finish their work. What we've been thinking in the past 10 plus years is how we can help then construction crews using our 3D design which we have. And let's face it, I mean, of entire project cycle, the engineering design is just there to show design intent to the construction crew, basically to give them all documentation and all tools needed for them to construct the project. So the traditional way is sending them IFC documentation, 2D drawings stamped, and then they need to go and build the station based on the 2D drawings. What we are trying is to visualize the project and give them actual 3D models so they can see what they need to build. I mean, construction people are visual, and we as a human, we are visual. We are living in the 3D space, and we are easily understand the 3D. So once when you see what you need to build, it's much easier for you to build it actually. So there's so many things we can do to help construction crew, to build better and faster and more precise and more safer, as you saw. One of the things is also very important is to follow up the project and to plan the project. These are tools on the market like Primavera, Microsoft Project. You put the schedule there, and to be honest, in most of the project I was involved, schedule is there, but it's never good enough. I mean, you have 40, 50 pages of Primavera or Microsoft Project, people going through that, and it's always hassle. What we've been thinking is how to put 4D element in the 3D. 4D element in 3D is actually time. So what you see here now is one substation, which is we built here. And by the way, this job was done in Nigeria, in Africa. So what we've been thinking is how to present to the people in Nigeria the best possible way how they can build a station. And we use this 4D technology to show this to them and actually to show to everyone. So what you see here, the software is called Navisworks. And Navisworks, what you see I'm using, it's a free version. So basically, you don't need to pay anything using this, this software. And you have the 3D model, which you cannot change. So this software is not intended for any design or change. This is just to view. It's like a viewer. So this is a substation. You see, I can walk on the substation. I can do different angles. I can rotate, But most important thing is I need to start planning now how to execute the substation. So the idea behind is we have a function called timeliner playback. So I put there, and I put on I have time lapse here. You can see I can go all the way to 0. And this is my 0 date. You see, it's a green field. And to do the scheduling, usually what we do, we call construction company. We sit in one room and we start on the day by day or week by week basis with the schedule. As you can see here, I have on the top day. This is day 1, week 1, and I can go increment. See day 2. So I can go basically day by day. So for example, day 5, 6, we are planning to put some fence around the site and to start roads. And this is something how we start building the schedule. We add additional functionality, which is called 5D or commercial or cost per project. So we categorize this cost on material, labor, equipment, and subcontracting. So as you can see here now, we are planning to spend on the first week so-and-so on material, on labor, on equipment, of subcontracting. Total project cost up to the week, day number 6 was, in this case, about 10K. So we can go now, I can put player, and you can see the player will go now, and you just build the station how we are planning. So again, this is all need to be done together with the engineering group, construction, and procurement. So as you can see, the substation is built here now, and this is my day 99, week 15, and this is going to be my plan to be for the work on that particular week, which is week 15. As you can see, the green area is meaning I'm planning on that week to do all this installation of these gantries, of these supports for the switchgear. Everything else in the gray supposed to be finished by that time. So I can just leave the schedule to go till the end, and this is my day 145, and that's my substation is finished. This is extremely powerful tool for the project manager. Just for example, if I go in calendar here, and I said my job will be finished by March 1st. So I can go on the calendar and say, somebody can ask me, okay, what is your schedule or budget by the end of the year? I can go in December 20, let's say December 19, and I can say, okay, my budget cash flow by December 19 is $97,891. That's how much I'm planning to spend until the end of the year, and this will be my progress. So now I can have here, you see, I can have plan, then I can plan actual and plan against actual. So if I go plan against actual and I go, for example, on the date again, let's say January 14, even better, maybe I can go even next step here. I want to see somewhere where I have some progress. Okay, here we are. This will be my progress report. Now, when it comes to the execution, we need to receive on daily basis or weekly basis reports from the site manager with simplified schedule. Basically, site manager can use this tool, just add the date and the progress percentage per each item. So instead to send progress reports in terms of Primavera, for example, 50, 60 pages, or Microsoft project, I can send one PDF picture like this, what you see here now. And my progress reports is like this. Wherever it's gray, it's finished. It was planned and it's finished. Wherever it's in a wherever it's in green, it's a plan to be done that particular week and it's progressing, which means we are on the plan. Wherever is in the red, meaning that I was planning to start those foundation here, but for some reason I didn't start, and I need to explain why. But since the site manager had enough resources, he said, okay, well, I cannot do this foundation, but I can do these gantries. So yellow means this is ahead of the schedule. So he decided instead to go and do the foundation, to go to gantries. Maybe for foundation, he didn't have concrete on time or some problem were there. So, but this is the real progress reporting, from the project. Now imagine you need to send to your executives or the clients or to the public, wherever, a report on the project. This is extremely well, really a tool which is visually tell you what is happening on the project on this particular day. So this is about our functionality, 4D and 5D, how we are trying to help construction companies to execute the job. Again, it's very important that you have collaboration with the construction company because they need to disclose here their schedule, their cost, and we can break down the cost of the material, labor, equipment, subcontracting. We can add as many groups here as we want, and we can really customize showing to the management or to the client or to the owner, to developer, wherever, how the project was planned, the cash flow per project, and complete execution. So that's about the 4D and 5D. Now I'm going to show you something completely different. Again, we've been thinking and we've done some R&D on the area. Okay, what is next steps? Okay, we do the job, we construct the substation, and what's next? Usually we submit to the owners, we submit as-built documentation, and usually the utility companies, which are our end users, our end clients, they have their own drafting process. We need to submit them in a 2D drawings, very, very specifics, and what we are doing, of course. But I think the life is changing, the industry is changing, and very soon everything will be digitalized, everything will be done with the new technology, the new generation coming, the tools are available, and like it be or not, I'm older generation as well, I think everything needs to be gone into the digital very, very soon. So one of the things which we've done research and we've been thinking a lot is, can we do the project without single drawing? Just having the 3D and giving to the people laptops or the tablets so they can have all information there. So basically, why we have drawings? Just to show to the construction group what they need to do and what they need to construct. What you see here is a web application. So the web application, meaning you don't need any software. So imagine you are on the site somewhere and you have this demo Horeum. We call it Horeum. Horeum is actually a Latin word presenting like a storage for the food in ancient Rome. And we use that name. So basically we want to show that everything can be stored under one umbrella and under one visual umbrella. As you can see here, this is a login form. I can have my name here and I have password. So security is the same like a banking security. So I need to put my password here and I can log in on the application. In this particular case, we have two stations. For the security reason, we didn't name the stations. It's just station 1, station 2, and we have 2 projects. Now I can go on the station 2. I have 3 stations there, and I can click on one, and I can have top view on that station. So you can see it's a complete access to the drawings, documentation, supports, visualization, and remote assistance and emergency. Imagine you are on the site, you have tablet, and this is your screen, what you see here now. This is a top view of the station with the red points, which are hotspots, which means you can jump. You see my mouse change when I go on the hotspot. And for example, I can go on the hotspot number 12, and that will transfer me into the station. I am in the middle of the station, which I need to construct. This is a green field, and literally you can imagine nothing is there, just a green field. Now you immediately understand what you need to put there. It's a complete, trench here. The building is there. All switch gear here is there, and all these dots you can go from one to. This is all hotspots, so I can jump from the top, and I can see my now top view. This is my station, and I know exactly, what I need to install there. Do I really need the drawing to see this? Maybe yes, maybe no. So I can go back on basically any station now. Let's say I'm back again here. So this is all preloaded, and again, as I said, this is a web application. So basically, you don't need any software for this. You see here, I have 3 dots on the equipment. I have my breakers, and again, to tell me this is my breaker 375, this is my switch 374, this is another switch 376. So basically, I can access any documentation about this breaker just clicking here, which I'm coming to that. But let's see first what we have on the menu here. I have all drawings here. So if I click here, I have station engineering, site preparation, protection control, and T-line drawings. If I go station engineering, I can have below grade, above grade, and the references. Let's say I'm going below grade and I have electrical and civil drawings. I can click my civil electrical, and I have construction drawings, I have vendor drawings, I have my standard drawings. Standard drawings usually are coming from the vendor, from the client. Let's see our construction drawings. Now I have all my drawings here available. That's all are in a PDF format, and they're all as built. Sorry, IFC drawings. So I can go in any of these drawings, I can open the drawing, and this is my cable schedule, for example. Now, if I want to print this drawing, I can just print here, and on the side printer, I can print this drawing. So still drawings available for you to print it if you want. I can enlarge this drawing and can see the details. I can decrease the view of my drawing. I can send my drawing by email to wherever I want. But one of the functionality which we've been exploring is as built. As you know, once the project is finished and you as a owner or client, you need as red mark as built drawings immediately, because the station will go in operations, and until contractor issue the actual as built, you need to have red marks. So you can do all red marks. You see this red mark here, you can do everything digitally as here. So for example, now I need to do some modification here. So I can just write up with a pen here and say, hey, this is my as built. And as you can see immediately, this said, if I can save my as built, it will said Friday, May 14th, it's done by me, and that's recorded. So I save this and it's there. If somebody else come later on, he can see document history, he can open it, he can see all as built marks, and who is done and when. So at the end of the job, you don't need to look after the drawings. Everything will be stored in one, how Igor said, truth element, which is a model or the drawing here. I have another functionality here. I can change, for example, and I need to send some comments to somebody else. I can put my green and I can do something green here. I can save that and I can send to Igor or to Ostap and say, hey, can you check these statements here? But it's green, it's not as built. So this also can be used as a collaboration between the site people and engineering. It's very, very important function, this which we cleared up about this as builds. So coming back to the drawings, as you can see here, we can go to take any literary drawing. I can go, for example, PNC drawings now. I can have cable schedule was already there, but I can have, let's say, diagrams, automatically close operations. I can have all my drawings are there. And I can, again, do the same functionality, you know, with the as built. If I want to save, I can just save this, and you don't need to do that. So you have here all your drawings. Then the second step is your documentation. Now you can have, again, for example, you can have like the resistivity test, grounding study. Let's say grounding study, you just open grounding study, and you can just go through the entire study, take what you need, and you can print, or you can have just take your information, and you are done. Serial, PNC, everything is here. Also, we have some support. We can have constructability movies, as you showed before. We can have safety movies. We have 4D, which I just showed you previously. You can be linked from here, so I can jump, if I'm site manager, from here direct to my 4D, check my schedule, come back here, all kind of the report can be done. Again, here I can jump just on my 3D. And then we've been thinking further, what is the obstacle for the construction people? How we can help them? And there's a lot of time spent coordination, and if you have some questions from site, to contact relevant people. So what we put here, we have assistance, remote assistance. If we have, for example, you can contact safety people, or procurement. For example, if I need to call procurement and see what's going with some of the equipment, I have the name of the procurement engineer here. I can call him. I have his phone number immediately here. I don't need to go and search everywhere. I can message him by Team, Skype, or I can by email, Viber. Basically, I can just click here and I can have him say, hey, Eddie, when this transformer is coming on site, or I'm missing some support. Please, can you advise where are they? Things like that. Or I can have my management or my engineers. You see, I have here my civil engineer, my PNC engineer, my station engineer. Again, same functionality. I can call them anytime. I have the number. I can go and text them. Everything is on the fingerprint. And one of the most important thing is emergency. We've been thinking about the safety a lot. We realize how safety is important and how we can help construction people to execute a job more safely. And one of the things is, for example, you have an injury on site and the worker is bleeding, and you really don't have much time to do any process. You just need to bring him to the nearest hospital. So what we've been thinking is we can have emergency contacts, for example, hospital, and we can click on the hospital. We have the address of the nearest hospital. We have the phone number, and I have the Google map. So if I could click on the Google map, it will automatically transfer me wherever I am now to that hospital. And you can see my route is I'm coming all the way from Ontario to the hospital somewhere in Texas. So this is very important function here, which is really, we wanted to think on the real situation on site. Then, of course, you have emergency contacts, you have fire department, police, safety. We can store all documentation there and, HST documentation and everything. So coming back to the model, as you see these dots, now you may need equipment documentation sorted a little bit differently. As we said, you can see all documentation on the drawing and documents from the pop-up menu down. But you can also access the same information group differently per equipment. Now, for example, if I click on my breaker, I have my manufacturing drawings, which I can click on my drawing and I have, this is my Siemens breaker, voltage level, I don't know, 69K, for example. So I can have the same functionality to the as-built, and I can print, I can do whatever I need. I have construction drawings related to to this breaker. I have some client specific numbers. And here we go now with how we call it 6D. Now imagine you are the owner of this station and you want to store all data about this particular breaker. For example, when it's a maintenance schedule, you want to have all maintenance reports available for you. Some maintenance notification. So for example, on this breaker, we need to measure, let's say, a main contact resistance every 5 years. And you want to have results. You want to check them, or the pressure, or SF6, or the oil pressure, or on a transformer, for example, oil status. So you can store all your data here, and you can have them available digitally within the literally press of the mouse. Instead to go and search all over the drawing documentation, everything can be stored under the same application, and that is the basic idea for this application which we use. And of course, operations, you may have some information there to build based on the client request. For example, how many operations this breaker had, or any data which is available on your SCADA or control system can be pulled and can be shown here. So basically what we wanted to present here is one application where you can have all data available in one spot, and data will be visually accessible. So this is something which we want to share, and this is our latest R&D, and I think I will finish my presentation here. Yeah, so Ostap, you can take over maybe now. Hello.
Sure, that actually wraps us up nicely with our last slide here on on question and answers, and I could see we have quite a few questions in the chat here that we could go over. Let me know if you can see my screen.
You can see all the questions and you'll address them?
Yeah, I could see them.
All right, why don't, if it's okay with you, maybe I'll just read them aloud one at a time and we'll address them just so everyone knows which question we're talking about. So first question is, how does this level of detailing affect the ability to consider, number one, alternate manufacturers' products such as or equal substitutions during construction? And I'll get the question to later.
Okay, I can answer maybe partially on this. During I'm just not clear during a construction, because we've been talking about having a conceptual design, then detailed design, then IFC, then having a 3D model during a construction as a support for a construction itself. And alternatives we usually check during a detailed design, right? Or even alternatives are also during a conceptual feasibility studies. Once when we get into the construction phase, we really don't deal anymore with at least major equipment with alternatives, right? If this question is related to alternatives to some accessories or some not major equipment, basically, then we need to think about what is actually in a 3D, right? So sometimes you don't want to have every bolt and nut in a 3D just to make that 3D to going on well on each device, on each computer, and so on. But however, you have all information about accessories, bolt, nuts, whatever that is, right, behind into the attributes of all those 3D models. Again, alternative manufacturers' data we already have in our database. During a feasibility, we can switch and see what fits better, if that is the case. During design, detailed design, we also, we update eventually our 3D models once when we received outline drawings from vendors, because that's very important to make sure that exactly what is given by vendor is used in our design, and we produce IFC 3D model. It's not supposed to change anymore, basically.
Basically, what Igor wants to say is once when we got drawings from the factory, and usually they are frozen factory accepted drawings, we check them against our 3D model. We are 100% before we go with the detail engineering, we 100% check every manufacturing drawing with our model. And if need to be updated, obviously we have to update. So we ensure that when it comes to the detail engineering, we are dealing with actual documentation from the factory.
This is Rick. I'd like to just add one point. If you can see the screen right now, this was an existing site, and this plays into one of the other questions that was asked. How do you do a laser scan? So, we'll come and we'll set up a scanning device that circles and spins and scans the entire area. Basically, what you can see gets scanned. If you need more precision, you can go to certain areas and get a little bit closer. For instance, with gas insulated switchgear, the tolerance is extremely tight. So at the interface where new and old equipment connect, we need to have extreme precision. And so that's just a function of how many scan setups we do and what particular device we use. But in this particular case, we had an existing switchgear in light blue color and an extension in dark blue, which was by the same manufacturer, but it was a newer equipment. It was a different footprint. And so getting to the point of different equipment manufacturers and selections, what you could do is scan this physical space as the owner and then decide, not all switchgear is the same. So whose can fit, what space I have left, what options do I have within that existing space based on the number of bays and switchgear that I can put in there, and then how would it fit and how would it look. And so in this particular case, it was the same manufacturer that was extended. The light blue was the existing, the darker blue was the new switchgear, and it was able to be matched up very closely.
Very nice.
Thanks, Rick.
Great.
I can take another questions from Mike. How are the engineering costs as a percentage of overall project cost affected by the use of 3D modeling vs traditional engineering? Well, we proved so many times that engineering cost actually can be even cheaper if you're using the 3D instead of the traditional 2D drawings. The reason is because when you do the 3D, you design in one space, and the drawings will be automatically generated. You don't need to worry about any changes to change 10 or 15 drawings if you change something on your concept design or detailed design. Drawings will be automatically generated. But please remember one thing what Ostap mentioned during the Stanford study. If you have 3D model as IFC and you present that to the construction companies during the bidding of the construction, you may get 7 to 10% better price, and that was study based on 32 major projects. What does it mean? Now imagine you have $100 million project and construction is $40 million. Okay? Now you issue IFC documentation for construction companies and you get the bid. If you save 7% of the construction cost just during the bidding, you save $2.8 million on the project because you get better price from the construction. 2.8 million. On $100 million, entire engineering can cost you between $5 and $10 million, depends on the complexity. So already there you saved almost half of all your engineering. So there's no doubt in our mind that the project will tremendously save using this technology from the beginning. You know, maybe cash flow a little bit, you will put a little bit up front, but bottom line would be the same, if not even cheaper, using the 3D engineering instead traditional 2D engineering.
Thank you for that, Frederick. We've been asked this question a lot, and so in the work that we're doing now and the projects that we're doing, we're gaining that data specific to our industry, specific to our substations, whether they're AIS and GIS, and we're documenting throughout the course of those projects specific examples where we saved or avoided cost. That's a great question.
Another question.
Ostap, can you go back just 1 second? One of the other questions was, again, how do you scan the station? And that's a 3D scanner that's placed in, and you have multiple setup locations. So Ostap, if you can just go to the top right corner where it shows the little bubbles where you can see the setups. And in the top right corner of one of these images, when it comes up, you'll see, yeah, right there, all the little circles demonstrate different setups for this particular scanning that we did on this particular site. That really becomes a function of what you're trying to do, what work you're trying to do, and what level of detail you need to gather from the site.
Yeah, okay. Yeah, there's another question from Joe. In future digitized world, do you have access to data relay settings and operational data equipment loading, etc.? What you saw in the last Horeum presentation about having all data for the project on one application, as you saw, I logged in that application, and that's a logging like in a banking system. Security is 100% there. And you can have that application on your server, your internal server, which means you can also give a different access priority to the different people. And for example, for your PNC engineer who are predefined, you can allow them to see all the data, even if they are available from the relay settings, loading data. Everything can be sorted in such a way that only approved group of engineers can have access on certain information. And also the question about security maintained is the same question. The application can be on your server, can have the access by the login and the password, and that's 100% secured, and will be controlled by your internal IT. Or you can pay that to the Amazon or the Google or any servers available on the market. Another question is, can project estimating software be incorporated into a model?
can cost be updated on the fly as the model is updated? Maybe Igor, you can take this one. I think Igor has a problem. I think we can, because what we are doing is for the certain equipment, for example, you have transformer as a model on the project. All information to that transformer is linked, is in the database, which means you will have the nameplate data for the transformer, you will have cost, and we can split the cost on the different levels, like cost, when a transformer leave the factory, it's one cost. Second cost is the transformer arrive on site, and third cost will be a transformer into the operation. So yes, it can be done. Have we done in the past? No, because we never had requirement. Please understand, we are an engineering company, and we are doing what our clients telling us to do, and they are paying us to do. And if we have this need, absolutely we can do it. Can engineering calculations, question by Peter, can engineering calculations be done with the 3D model, force calculation on buses, ground grid calculation, structural calculations, without having to rebuild models in another system? Unfortunately, Igor has a problem. I think he would reply to that question. But our model, wherever each software, calculation software, he can import 3D model from CAD. It can use for the calculations. I know that certain softwares can use 3D model. For some certain softwares, you need to build inside that particular software the model. But definitely this will help, if you have 3D, to build. And it really depend on what kind of calculation, what kind of software you need. It's a big area, so many softwares there. And again, as Igor mentioned, it is about the software, but more it's about engineers and to be clever, to be, to think out of box and to think how to link all these softwares together in order to get the best results. It's another question from Sunil. GPR for below grade. Please inform how are the costs for typical substation, example 10K. Please inform the depth in feet below ground of data visible through the GPR. Thank you. Again, GPR is really limited by the equipment you are using. These are all kind of GPR equipment on the market, scanners who can do and what we are not surveying company, we are not using them. We are usually subcontract, or we can if need. But what we take from the GPR equipment is a 3D model or the data, what they do, and then we can put that data in our model. What you see in our below ground 3D, the below ground is a big issue because so many things are happening, and especially safety. I mean, when you start digging and if you don't know what below, a lot of things can happen. So what we are doing, we are making a first 3D model of the existing situation based on the below ground drawings. So we collect all the drawings and we put in the below ground 3D. Then if we have issue and client telling us, hey, I don't know, something happened here, but we are not sure, then we call GPR into the picture. Then we engage GPR surveying company, and then we take the data from the GPR and we put them in our 3D model. The cost for the GPR scanning, really, we need to check with the local surveying company because there's so many companies down, doing the GPR these days. We are not doing physically by ourselves. We know how to do, we can, but it's not our business really to do surveying. I hope that's an answer on the question.
Okay, can you hear me now?
Yes.
Oh, finally. Okay, today is definitely not my day for electronic devices. So anyway, I will just add a little bit on integration with cost estimating software and our 3D. It really depends on, as Predrag said, on the software, but there is a really when you're using intelligent tools in 3D modeling, you can always export data as CSV format, right, which is the spreadsheet format. And regardless of what is on the other side, I mean, which software you're using for a cost estimate, you can, by having a CSV data, you can always pull from other side, and really quickly in a matter of, I mean, you can also set up the macro. That's what we usually do. Really quickly, you can have updated cost of the project or of the feasibility concept, right? So that's really not a problem as long as you are using, I mean, each of these software on the market, they all have a way to export attributes which are attached to the model, right? As basically spreadsheet data, Excel data, or CSV data. Second question, I think I've seen, I wanted also to jump in, but I couldn't. Yeah, now on GPR, of course. I mean, usually you have some information about underground obstacles, underground services, right? The point is that in reality, engineers put something on paper, but then when it comes to the execution, especially underground, in certain cases, and of course, if those stations are dated from 50s, 60s, and so on, those locations are not exactly as per drawing, right? So GPR as GPR findings are good because they can recognize that something is in the ground, but the GPR itself cannot really give you description of what that is. So there are certain ways how you can discover and figure out what that obstacle is, but it's all based on the density of the signal bouncing back from the obstacle which is in the ground, right? So it could be, you can judge based on that, based on the frequency you're getting back, if it's a clay pipe or it's basically something made out of metal or some piece of concrete as a duck bank, for example. So then you compare with whatever data you have, and you try to recognize, again, this is this is not done by any software, this is done by people, right? So you compare the data with the data that is in our archive, and you try to recognize your obstacles, right? That's one way of doing it. If you cannot, you can still mark your drawing before construction is start, and indicate that something is underground, right? You can try to avoid by your design, or if it's not possible to avoid, then at least you can involve your construction group and let them know that they can expect something to find in that area, which will affect the price, obviously, and it will minimize risk and unknowns at site. Okay, what else? I think that's all.
Okay, any more questions? Feel free to type them in the chat. I just wanted to say a couple things. I want to say thank you very much to RCM. This was a great presentation. I know we had some technical difficulties, but you guys did a great job getting through that, and that stuff happens and we understand it. And thank you again. Hey, just as I mentioned a little bit earlier, a couple of things with the CEU certificates. I just put the link into the chat function to get to that web page where you can do your evaluation. Please get that done as soon as you can, hopefully before noon today. Also, it takes a little while for the GoToMeeting to compile the recording here, but I will load that also later today. Let me just get that link. I'll load that as soon as I get it, and everyone can download or look at the recording of the video later as well. So with that, I do want to take the summer off. So we'll be back in September and pick this up again, probably virtually, but we'll see what 2022 brings. Maybe we'll do a combination of virtual and in person. But thanks everyone for participating. Thanks RCM again for an exceptional presentation. And we're going to hang on the line for a little while in case anyone has any questions.
Yeah, Ron, how do I get EU for this class? This is Dinkar Desai.
Yep, if you take a look in the chat, I put a link there. Hopefully you can still see it. Scroll up a little bit. It'll take you to a website where you put your information in, do the evaluation form, and it's an automated process now. So thank you so much, IEEE, for automating that for me, because it was a killer.
Okay.
Ron, thanks again.
You're welcome, Bill.
Thank you.
See you soon.
You're welcome, speaker.
Where's this
Ron,
chat
thank you very
button?
much. Frederick is here.
Where's the chat button?
Oh, in the top right, it looks like a bubble. I'm assuming your screen looks the same as mine. 3 over from the right. You see the dot, you see the little gear, then you see the bubble.
Yes, I'm not seeing it. Which screen?
Can you, if you send me an email, if you can write this down, it's rwquade@IEEE.org. So RWQUADE@IEEE.org. I'll send you the link if you can't see it on the website.
Okay, RW. What?
So it's RWQUADE@IEEE.org, and I'll send you the link.
IEEE.org, okay. Okay, I'll do that. Thank you.
Cool, you're welcome. While we're hanging out here, I gotta say, I think this may have been a record for us. We had 208 registrants, so pretty good topic and a lot of interest.
Yeah, thank you for the presentation.
Very good.
Thank you for your time. Really appreciate.
Thank you, Ron.
More than welcome.
Thank you very much for hosting, and thank everybody for the great questions. I mean, that's the most interesting part for us. We want to hear what's on your minds, and this is really rapidly evolving, and so many innovations are coming out of this that we're excited to see what happens next. So any follow-up that we can provide, we'd be very interested to do that. And you know, Ron, I don't know if you need to close this off at 11, but we could even stay on if there's any additional questions.
No, we'll hang on. We'll hang open. I have unlimited time. We'll hang open for a little bit until there's no more questions. So, but interesting times and amazing what the technology can do these days. A lot of help.
This is Mark. You said there was a link for today's presentation.
Yeah. So what GoToMeeting does is I recorded this, and it takes a couple of hours to compile it or whatever it does. Once that is done, I will load it to the link that I am sharing in the chat function now. There's probably nothing there now, but when I get this, it's a couple hundred megabytes. I'll load it to that OneDrive, and you can access a recording of this.
Okay, thank you.
Does that answer the question? Okay.
Is that OneDrive link going to be in the chat on this screen, or is it going to be in the original email?
It's both.
Should be for the registration.
Invitation a couple months ago, so I didn't forget it. But if you take a look at the chat, there should be a link there now. Should take you to the OneDrive. It's going to be empty for a couple of hours until I get the recording downloaded. But can you see that in the chat?
Hey, Ron, really outside send OneDrive link to our RCM's social media probably on Monday.
So guys, if you have any problems seeing the chat, you can always email me at rwquade@IEEE.org, and I'll make sure you get it.
Okay, thank you. I appreciate it.
You're welcome. Yeah, there's so many different online tools out there. I sometimes get them all mixed up, but you know, if you're not used to using GoToMeeting, just trying to find where the chat is and the links and everything else can be tricky. So, anyone else have any questions?
I had a question about the PDH.
Sure.
Yeah, just wanted to know, do we have to complete a form, or no, we are just going to get through email?
Yes, so if you take a look in the chat, I'll try to copy and paste it again because they get buried quickly when there's a bunch of activity here. Basically, if you click the link, let me put it in there again. If you click the link that I just posted in the chat, it takes you to a web page, asks you for your information, asks you for which seminar you're completing this evaluation. I think there's only one in there now. But if you just answer those questions, it's an automated process. Probably within the week, you'll have your certificate. It'll be emailed to you from IEEE headquarters, and it's 2 hours. So it's 0.2 CEUs or 2 professional development hours.
Okay, thank you.
You're welcome.
Hey, Ron, it's Tim.
Hey, Tim.
Hey, I've been missing these sessions over the summer with you guys. It's really nice to have the tech repartee, if you will. But yeah. I hope you enjoy your summer off.
I will. Thank you.
And if you're lucky, I bet you end up getting to go to Happy Valley for at least a couple days.
That sounds good. I hope so. My kids are both back now, so.
Good. Well, hey, thanks much. Have a safe summer, and I'll look forward to September time.
That sounds good, Tim. Thanks so much. Thanks for all your participation. All right, have a good weekend.
Bye. You too. Bye-bye.
This is the best part where you get to catch up with people. When we're in person, it's a little bit easier, but remote, it's a little bit of a challenge.
Yeah, I was listening. To be fair, you don't get to see me, but I get to see you.
That's right.
I think a long time ago I had a situation where my video was on unexpectedly. It might not have been on this particular feed, but yeah, I probably scared everybody.
Yeah, that's cool. You know, one of the challenges I find, like we use GoToMeeting in my business, and I like it. But there have been more than one occasion where it's completely frozen my computer, and I'm hosting a meeting and I'm stuck. I mean, what can I do? I can't reboot my computer because I'll probably cut everybody off. So I have to go to my personal computer and log in as a guest. But that's one of the problems with some of these technologies, the bandwidth. GoToMeeting hasn't been too bad. But like if you put your video on, it just really, takes up all your bandwidth and causes other problems at times. So it's a balancing act. I mean, I think all these technology companies threw this out there when we went into lockdown, a year ago. So, they're tweaking their systems and making them a little bit more efficient. But yeah, some problems still, as we saw today, right? Things happen.
Yes, I actually, I didn't send this yet. I'm about to, but that's one of the things I mentioned in my feedback form. Okay. Nothing derogatory. It's just, hey, this is still working through.
Right.
But the other, I'll just read it because I'll tell you what I said. I don't know if you see these forms or not, but what I said was, and there's problems when you meet in person too. So,
yeah, right.
But it's been quite enjoyable.
Good
for me. I didn't have a lot of questions. I was so enthralled by watching things. I didn't have questions so much as everybody else did. I was enjoying just the technology aspect of what they can do. But there was another. I don't know if it was with you guys or it was another session that I attended. I think it may have been with Eaton. A similar topic, but not nearly the same. Of displaying the technology aspects with this.
Yeah.
This was really, it was they weren't being fancy. They just showcased an awful lot and may not have realized it. How's that sound?
Okay. Yep.
That's great to hear. Thank you very much.
Anyway, I'm going to let you go. Again, enjoy your summer and weekend.
Thanks, Tim.
Have a great day. Thank you. Bye-bye.
Bye-bye. Guys, I think we're just about done. Anyone else have any questions or comments or want to say hello or anything?
Yeah, hello, Ron, this is Herman.
Hey, Herman.
Another good presentation here. It's very interesting, deep. The more you look, the deeper it got.
For sure. Well, thank you.
And I still have some questions. Boy, I could just see some of our contractors coming up with change order on top of change order when some minor, don't line up. When you do this level of design, it better assemble like, you built a million of them.
That's right.
Hey, Herman, I had a presentation to one utility company, construction company, and a friend of mine who's working for the construction said, Predrag, the construction company would not like your ideas. I said, why? Well, they said, the biggest money they make in the change orders.
That's right.
That's right.
That's right. Takes one out of the game.
And sometimes they package their change orders as you know, an or equal piece of equipment that in my work, by law, we have to leave it open to or equal. Well, there's going to be some slight differences in dimensions and things like that, one manufacturer to another. And each one of those, a contractor can claim as a change.
Right.
Right.
So our design documents then need to address how change orders are justified depending on what angle they came in from.
Yeah, very true. It's tricky.
Yeah. I've had a contractor come in and say because of our consulting engineers approved the substitute piece of equipment, and then ultimately that substitute piece of equipment, it needed different anchoring and foundation footings, that was an additional change order. We tried to tell you guys submitted this alternate manufacturer. You're responsible
so funny.
with it.
Too funny.
Be a battle.
Yep. That's
So this technology is when you're a contractor and you have an EPC job, this is also where the contractors like this technology because they're responsible for delivering a project within a certain budget, and this technology ends up helping them to keep and maximize their profits. If you are familiar with more commercial construction and how they've been doing their business the past several years, they make heavy use of this same technology, and they're able to essentially win bids and keep their profits high by using this type of technology. So it is a double-edged sword. You know, it's certainly from a traditional construction perspective, where when you're in the substation, you know, business, yeah, this is going to definitely cut costs at cost, but longer term, the contractors are going to find ways to leverage this technology to their benefit as well.
Yeah. You sound like you're in the field, Joe.
Yeah, I mean, definitely I've done design and I've supported construction. I know what it takes to take a job from cradle to grave, and even once the job's done as built, when you take a look at what was presented today with the RCM software, I mean, we presented a tool that can be used not only to design the substations, but to actually assist your maintenance and operations personnel and use this 3D data for operation and maintenance purposes. So that's you know, another point behind this technology that's very important, because sometimes, and I've seen this over the course of my career. One of the first jobs I saw when I was a young engineer 20 years ago, we did a 3D model. And that 3D model, it helped us find interferences, save costs. And at the end of the job, it was more or less thrown away because it didn't integrate into the way the utility was managing the drawings as far as, you know, they filed 2D drawings, they didn't file 3D models. This software has the ability to follow the 3D model, make use of the 3D model, and have the links within it to bring up schematics or be able to show the 2D information that needs to be used. That's, to me, one of the most important parts of this software that we're looking at, is that there are new ways we can store this 3D technology and leverage it into the future.
Yeah, pretty good. All right, awesome. Well, hey, thanks so much. I'm going to end it, and everyone have a good weekend. Thanks for the participation as always, and see you in September.
Thank you, Ron.
You're welcome. Bye, guys.
Thank you, Ron, for
Ron,
setting this up.
Ron, thank you very much. Ron, you're great. Thank you.
Bye, guys.
Thank you. Bye.
Bye. Have a great weekend.